Hello. Hello, YouTube. Welcome to the Wednesday Solder Sesh. We have more Nixie kit madness here. And let's see if I can zoom in a little bit here. That's pretty good. So you might remember this from a couple of weeks ago. And yeah, the goal is to put more of this kit together. And I've already taken a stab at these sockets. The Nixie sockets are going to be definitely the hardest thing. Let's see if I can get a little bit more light over there. There we go. Yeah, they're going to be very challenging. I'm probably going to try a few different ways of soldering those, but we'll see what happens. So yeah, is anybody out there watching? You guys should post comments if you are. I have Robin here with me today, if she wants to say hi. Hey Jason, how's it going? Robin is on the controls. She's been working with me for like 2 years now, I think. Yeah, I know, right? She keeps this place running. She keeps us, in kits and in yarn tools and shipping and all of that stuff. So that is awesome. All right. So I should probably tweet about this. Whoop, tweeting. Yay. And yeah. All right. So yes, those sockets. So they're gonna be tricky. These ones I just soldered in by hand. I placed all of them very carefully, and then I uncarefully bumped it, causing them all to jump out and half of them to fall on the floor. And then I was, on my hands and knees on the floor, trying to pick them out of the carpet and find them. And I found most of them, but I still didn't find one of them. So hopefully they gave me extra sockets with this kit. Otherwise, I'm going to have to be tracking down these particular ones. But the thing was, so I then took a piece of blue tape, good old blue tape, and I taped them down, and then I flipped it over and soldered them on the back. And that worked pretty well, except that it's really hard. Like, you can't get them perfectly straight. And my Nixie tubes here, so this right here is a Nixie tube. You can see, let's see if I can get this in the light well. So you can kind of see all the digits that are in front of each other. And they're in some sort of kind of funky order so that you minimize occlusion. So it's not just like 1, 2, 3, 4, 5, 6, 7, 8, 9. It's some other funky order where it looks like 6 is in front, and then maybe 4, then maybe 7. So yeah, it's kind of cool how they do that. But these are used Russian Nixie tubes. So you can see here that the pins aren't perfect. They're not perfectly, perpendicularly aligned. And so now fishing these into the sockets and having to do 11 or 12 of them or something, probably 12 of them all at the same time. That's kind of challenging. So yeah, so we're going to see how that goes on this one. No promises. And then, so this one, I think this was your idea, Jason, of putting all of the sockets on the tube first. So that works reasonably well because there's still like a little bit of solder on the leads. It's hard to insert them, but probably easier to do it like one at a time while the tube is out than it will be trying to, do all of these guys. So I put all those in, but then it's still really hard to like line all of these up and get it to insert into the board. I don't know. I did get this one in here, and it probably took me like, I don't know, 10 minutes or so and a lot of cursing. And I did get it done, but then we really want to solder those. If I do it that way, I want to solder them last. And you'll notice that the middle, there's a pattern for an RGB LED. So, which is cool because it kind of like underlights the Nixie tubes. So if I want to put those in, I definitely need to solder those in first and then solder the Nixies on top of it. If I'm going to solder, you know, the Nixies with the sockets on already. So yeah, a lot of thinking about different order and things like that. So yeah, basically I think I've come to the conclusion that I'm going to save the sockets for last because they're definitely the biggest pain in the butt. So meanwhile, can you give me that? Oh, thanks. Let's see. Grab that. So we have still left to go. We have some resistors. Let me just grab all of this stuff out first, and I'll give it back. Cool, thanks. So we got some resistors. Those shouldn't be too bad. And then we got some ICs, which just get inserted into the chip carriers. We did the chip carriers last time. They're right here and right here. And so those can basically be saved for last. We have a little battery, a little backup battery. I think it's for the real-time clock. And then these are the RGB LEDs that go inside the Nixie tube patterns. And then we have two different types of transistors. We have A92s and A42s. So I think maybe what I'll start with are these A92 guys, and we'll figure out where those are going to go. So this is where old eyes happen. All right. So A92s, all of those guys look like A42s, I think, that we can see on the screen right now. Yeah. These guys are all A42s. So we got an A92 over here. Let's see. A92 over here, A92 there, A92 here, 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 and there. Ooh. I wonder what that guy is. That looks like something completely different that I'm not sure if I have. Let's see. Oh, maybe it's in this one. Maybe it's in the bag with the A92s. So I'm looking right now at all of these guys. They all do say A92 on it, except there's one. This guy. Yeah, that says A92, I think. It's just like kind of double, triple printed. I don't know if you could really see that, but yeah, it's kind of weird. Awesome. So let's see. I don't think there's a different part in those. I wonder if there's a different part in here. These are all loose, but I don't want to confuse them with the A92s. So I'm gonna keep that mystery till later. So the thing about transistors like this is that, let's see if I can get it a little bit better, is that they are directional. You can see that they have sort of like a little D shape to them. So they have a flat side here and then a roundy side. And that's why the footprints look like that. So you basically just match it up so the flat side's on the flat side, round side's on the round side, so that the silk screen all matches up, and then it should be in the correct orientation. The other thing about these is that the pitch is relatively fine on these guys. And when I insert it into the board, the spacing between the holes on the board is actually like a little bit bigger than the spacing is between legs. So you can see like I can't, let's see, this guy, I can't really like push it down all the way. Let's see if I can get an edge view of this. Let's see. Yeah, so you can see here that there's like a little bit of a gap between the legs. They're not having as good light this time as we did last time. Have to figure that out sometime. But maybe let me try one more thing. Try maybe getting this light on. See if that helps at all. I think that's maybe a little bit better. So yeah, you can see that I can't push it down all the way because it's actually like splaying the leads out like that a little bit. And that's fine. You basically just push them down as far as they'll go. And the reason that people make the hole spacing a little bit wider is because if they just left it this wide, it's actually pretty hard to solder because you don't have a lot of area around the holes for the pad, and then the pads are super close together and it's really easy to bridge them. So that is why people do that. And you can actually buy transistors that have legs that are like pre-bent and spaced out on like a 10th inch header spacing. Hey Brent, how's it going? But they tend to be a little bit more expensive. They're called like lead formed transistors. And so when the leads are preformed, they tend to be a little bit more expensive. So they don't tend to quite be as common with kits, unless you get one of our kits. Because we do buy the preformed ones because they're just a little bit easier. So, all right, without further ado here, let's like solder a transistor. And let's see. Yeah. So today I'm using a slightly different soldering iron. It's a new soldering iron to me, but it's one that a lot of makers really swear by. It's the Hakko FX888D. And it's like the blue and yellow one, basically. And it's about $100. It's a pretty nice soldering iron for $100. Has like nice tip control temperature. And this tip is a little bit of a blunt tip. So it's definitely like a lot blunter and fatter than what I was using last time, which was that little bent hook-shaped tip. And, it's pretty nice to solder with. It transfers heat really well. You saw that, those three just went super fast. You don't have to worry about like making perfect contact with the pad, even if you're just like, a little bit, even if the whole tip isn't on the pad and just a part of it is, there's like so much heat being transferred that the solder just melts and it flows to it, no problem. So yeah, pretty nice little iron so far. I kind of like it. The ones, the Metcal and stuff that I have a Metcal and I have a Weller, an older Weller, like digital one. And those are both, $350 soldering irons. So, if you're doing a lot of soldering, totally worth it. But if not, and if you're a little bit more on a budget, then like $100 Hakko is pretty nice. All right. So more A92s. See about placing a few more of them. Oh, and so because I have a feeling, especially with the pain in the butt of the socket soldering, Have a feeling I'm not going to get to the point of firing up the Nixies tonight, but that's okay because we have a super cool piece of vintage equipment that my friend Tom loaned me. Actually, he kind of gave it to me. He's on a mission of getting stuff out of his garage. And when that stuff is like vintage electronics equipment that's still functional, like I'm here for it. So anyway, he gave me a super cool HP electronic counter that has a Nixie Tube display on it. And yeah, as you can see, sometimes it is easier than others to like get these guys in. I'm just like bending the leads out a little bit to make it easier on me. There we go. So yeah, so it's an electronic counter with a Nixie Tube display. You know, it's basically a frequency counter. So it counts pulses, and it has a few different modes. It can just count pulses, just like pulse counting mode, or it can actually tell you what frequency the pulses are coming in at if it's, you know, a repeatable frequency, or it can tell you the period, so how much time each pulse takes. So that is all kind of cool. All right, let's see. So I've now put in like that line of A92s. Did I miss any?
And are A92s different from A42s?
You know, they are, just... and I'm not sure what the difference is. I don't know if did they give us some bill of materials here? Like, I'm guessing maybe one is a NPN and one is a PNP or something. That like one is more like positive voltage actuated and the other one is like more negative or negative current actuated. But I am not entirely sure because the A92 and A94 is actually not the part number. It's just what's written on the part. And so the part number is probably it's probably like a lot longer. And without the actual part number, it's hard to look it up and know exactly what's going on. So let's see. Yeah, they didn't really give us like a full bill of materials with this. So I'm not actually sure what they are, and they don't have a schematic with it either. I might see if they linked to any on the in their Tindy store. They might have. All right. But yeah, that's a good question. They are definitely different parts, definitely do different things, but I'm not sure what is what. All right. Now let's see if these guys will stay if we flip them over. Haha, yes. Excellent. Because they're splayed out a little bit, they have a good amount of friction. Oh, there we go. Nice, Brent. Thanks. NPNs and PNPs. Oh, from memory. He's got all the part numbers. I love it. Nice. MPS. What manufacturer is that? It's not a prefix that I am totally familiar with. All right. Nope. Maybe I should put this in view. It might be more interesting. More interesting. There we go. So yeah, this is like
Motorola.
Oh, Motorola. Yeah. Okay. That makes sense. That makes sense. Now likely On Semiconductor, right? Unless On Semiconductor's gotten bought by somebody else. I can't keep track of all of the semiconductor acquisitions over the past like 20 years, right? All right, so now we are just like going down and clipping all of these guys off. That there. There. So pretty sure I got all the A92s. So now I'm going to look through this bag of A42s. And I'm going to see if I also have like one extra oddball out that is like, it looks on the board, it says 18B20_1 for that guy. And I'm like really not seeing that part. So we'll see. It's, I mean, the only other part that had 3 pins that was sort of like that was like the IR guy, but that, I mean, that's obviously this guy right here. There's not, I don't think I would have mistaken that. So yeah, let's see if we have like one other transistor. Oh, hey, look at that. Dallas. Oh, this might be a temperature sensor, maybe. Haha. Awesome. All right, you are the odd man out. So I think I'm just going to solder it while I have it here in my hand before I lose it and mix it up with all of the transistors. And just to make sure, it does in fact say 18B20 on it. This is probably not going to show up, but that's okay. Oh, we could, yeah, let's, okay. We're gonna lose video for a second. Don't panic. We're just manually switching it to the microscope view here. Let's see if we can do that. Maybe. Or maybe not. We don't have a
Does the computer need to be like,
no.
Oh, there we go. Oh, it's just because it's dark.
Oh, it's just because it's, there we go. Haha. All right. So we do have a super close-up microscope view here. Let's see if we can get some more light on it. Maybe. Haha. Yeah. The microscope does have a light on it, but it's just far away right now. So anyway, we're still kind of trying to figure out how to get that guy. Ooh, I know. How to get that guy in our live stream loop. Hey. So yeah, that is our 18B20, which I'm guessing is a temperature sensor. So cool. Awesome. All right. I think we can switch it back to the table now. Yeah, it's definitely funny the amount of stuff you need in order to get like several different camera views and light on situations and things like that. Definitely still like working stuff out and optimizing our setup here. All right. So you are going to go in here. Come on. Get in there. There we go. Awesome. And flip you upside down and solder you. And we are still like using lead-free solder, committing to our new lead-free selves in the new space. I have to say lead-free solder is definitely, it flows nicer than it used to. when it first came out and was like super expensive and was terrible. Awesome. Oop, should clip those leads off before doing anything. Cool. All right. So now we're on to the A42s. A42s. So I think I'm going to do that little cluster right there first. Why not? Why not? And then after I do this little cluster, then we will do more camera angle shenanigans, and I'll show off the electronic counter. I just figured I would wait till like 5:30 to do that, sort of half stream maybe. Although I don't know, the past couple we've taken 2 hours, but I think it's my goal to kind of try to do more stuff in 1 hour, but I don't know. We'll see how it goes. This is definitely going to be more than an hour to be fully done, but that's all right. Cool. So yeah, I'm just like taking my fingers and just like slightly splaying these legs out just to make it a little bit easier for them to get fished through the hole, all the while keeping track of which side is the flat side and making sure that it lines up to the flat side in the silkscreen.
Do you find it easier to kind of rock it in than trying to go straight in?
Yeah, I kind of like get the middle one in and then like rock it to either side and get like the right and the left or the top and the bottom. Because like once you splay them out, they're at slightly different lengths. Yeah.
Oh, since the middle one's
like straight, yeah, and the other two are at an angle, they end up being like a little bit shorter. But it's not too bad. Like you can just sort of like eyeball it and then fish them through. I guess this one I'm starting from the side just because I can see it better that way. So I guess it just depends. All right. And get this little NPN farm all soldered up.
It is nice that those now have tension, so you don't have to
Yes.
find a way to keep them in there while you're soldering them.
Totally. It is definitely nice how that worked out. What are those, I wonder? I'll turn it back over and find out in a sec. No, I'm like, what is that pattern for? Yeah. And they don't need like a whole lot of solder added. This is a little bit of a different angle than I'm used to soldering at because, you know, I can't be straight down or else my like head would be in the way of the camera. So it's like a little bit more at a 45 than I'm used to. And so, yeah, it's a little challenging. Doing this stuff live, but that's okay. I'm up for it. All right, let's see. These three. It's like sometimes like a little bit of a mix of looking through my magnifier here and like looking around it. Like, oh, did I get that? I think I got that. I'm going to tilt it up towards me now here just so I can eyeball it. Yeah. That looks soldered and it doesn't look like anything is bridged. So I am happy with that. And also, you know, always trying to put away the iron with blobs of solder on it. Put away the iron dirty, so that helps with oxidation. All right. Yeah, it's definitely easier for me to clip these, like looking around, looking around the light.
And pinching the leaves as you clip.
Yeah, I do that so that they don't fly everywhere, so that they just stay in my hand. With really like fat leads, that can sometimes kind of hurt because they shoot off with such force. But these are all like really small, so it's not that big of a deal. But yeah, it's just nice to keep them all out of the carpet. And like, especially if you were doing this at home, you know, where you might be barefoot sometimes, you wouldn't want like little metal things in the carpet poking you. All right, cool. All right, let's show off this super cool Nixie counter. And let's see, how do we want to do this? Let's put this in the spotlight. Woo! All right. And then if I can ask you to hold that, Robin. Awesome. So, so this is the electronic counter. And as you can see, it has awesome Nixie tubes. As you can also see, this digit is a little bit bustificated. So I will eventually take the lid off and see if it's, you know, if I can figure out how to fix it. But for now, just ignore the 4 there. Pretend it's a 0. So what we're seeing right now is it's on frequency counting. So we're seeing 1.000 kilohertz. And that is, in fact, what our Regal scope is outputting. It has a little waveform generator, so I'm using it to generate the waveform. It goes out the back of the scope here, and then goes into the input here. And then this guy is telling us that, yes, it is indeed 1.000 kilohertz. This is probably going to be too tiny to see, but the frequency is displayed right there on the screen. So what's kind of cool is that we can then adjust it, and like, let's put it to 5 kilohertz. And then our counter is slowly adjusting. 3, 5, woohoo! And then you can also like reset it, and then it'll take a second or two and then tell you what the frequency is again. And then if you want it to tell you what the period is, or how much time it takes each pulse. So now we're on measuring period, and so we're getting 0.2 seconds, which makes sense for a 5 kilohertz wave, because the period is just 1 over the frequency. So if you're doing 5,000 pulses per second, then each pulse is taking 0.2 milliseconds. Sorry, this is a millisecond. Millisecond display. So yeah, it's kind of neat. It also goes all the way down to microseconds. I'm not sure what the maximum frequency of this thing is. That would be something cool to figure out. But the other cool mode that it has is just like a pulse counting mode. And so that's that's kind of like the money shot of the cool Nixie-ness. Of course, it's going so fast that like pretty much these digits are all on all the time. You can see this one is sort of, you know, going up and counting. There is a little bit of a weirdity with this digit, as you will just be able to see that 2 isn't really working. So yeah, it fuzzes out like that and then goes back up to 3. So yeah, but that's cool. So if you had something that was kind of like irregular, that didn't have necessarily an even a regular frequency to it, if you just had, you know, different pulses happening at different times, then it could still count those. So yeah, that's about it. Let's see, there we are. I'm gonna reset it so that we, oh, interesting, that digit is looking like it's a little on the fritz too, but not bad for like a, oh, there we go. Not bad for a piece of equipment that was probably made in the 1960s. So yeah, cool. Awesome. Put over here again. Maybe. All right. So yeah, Does anybody have any questions about like the cool frequency counter or the Nixie tube display on it? Maybe, maybe not. Yeah, I feel like I need to like come up with a really cool excuse to use it, and like to use it over some sort of different kind of counter. Awesome. All right, so we have another little farm of A42 guys right there. And I think I will put those guys in and solder them in.
Brent said, thanks for that demo. Seeing the most significant digit go from 4 to 5 is a big troubleshooting clue.
Interesting. I wasn't looking at the at that one that much. We were poking around it the other day, and it didn't seem. I don't know. It didn't seem super regular, but I don't know. I have not also fully delved into it. So yeah. Like it doesn't necessarily always react in the direction that it should, if that makes sense. But I'm curious to hear what you're thinking though is the issue. Because it could definitely, be like a variety of things. It could definitely be, one of the pins of the tube is corroded or just not working or not making a good connection, or it could be whatever is driving that as well. My friend Tom, who gave this to me, found an interesting schematic of a similar era one, and apparently, like all of the Nixies are driven by photoresistors, so it's all like an optical connection from the transistors, which are triggering and essentially doing the counting, to the Nixie tube display, which I thought was kind of neat. Which, is also nice when you're dealing with like 170 volt things, right? To kind of isolate them from your lower voltage electronics. Let's see, there we go. There's our little farm. Awesome. Yeah, and I should also mention, so I might have just bridged those. There we go. So I just bridged them, but I fixed the bridge by essentially poking my soldering iron in the middle of the two pads and just like wiping up. And that just moves, since the solder kind of follows the heat, it follows the tip of the iron and moves some of the solder up the lead instead of leaving it at the bottom where it was like bridging across that gap. So there are a lot of little tricks like that that you can do if you don't have solder wick, or or if it's just easy to fix without solder wick. You can even actually, and I want to try to make a video of this, although it's going to be challenging to do that. You can actually get solder out of holes without solder wick. And so you can actually like heat up the pad. So I'll do a pretend demonstration. So like you can, if the pad was completely plugged with solder, you can heat it up. And then, now this is assuming that you don't have anything that is like super delicate on the board. So then you like pick up the whole board, keeping contact with the pad and the soldering iron, and then you just kind of like slam the heel of your hand on the table and the force of the impact will like make the solder drop out of the hole. And it doesn't always work, and it definitely takes some practice to kind of get right. And it takes, of course, with anything like with removing solder, sometimes it takes adding more solder in order to remove it. So if you just have like a little bit of solder in the hole, it won't really work. But if you add some more solder and you have like good heat transfer and good flow, then that does sometimes work. All right. It's always good to remove any other ones that are just sort of like hanging out on your board so that they don't accidentally short. All right, let's see. So we got a few more A42s now. I probably should have checked to make sure that they didn't give me more than one of those temperature sensors in this pile. I don't think that they did, but now that I'm thinking about it, maybe I'll just check and make sure. But yeah, they all look like the transistors. And I'm really hoping that all the ones that I've already soldered look like transistors and not temperature sensors. And yes, they do. So yay for them having not given me any extra of that one. All right, let's see about that guy in. And this guy in. And do this one at the same time. Maybe sets of 3 so that I don't lose track of where I am and have one accidentally fall out. I also like how on this board there's like one component at a 45-degree angle, that diode. It's like, oh, need to fit that in there. All right. So here we go. I have to say, I'm definitely hoping that this kit works when I fire it up, but we'll see. We shall see. I feel like there was one more. Nope. Okay. All right. That one there. All right. I was curious about these lines of holes and what they go to. Oh, they're the resistors that I haven't soldered yet. Look at them. Okay. So they're the rest of the 470 ohm resistors. That makes sense. Cool. All right. Yeah, I'm not sure. I'm still thinking about the sockets. I think that they're just going to be a pain in the butt. I don't know. I'm not really thinking of any way I can possibly make soldering in those sockets and like lining up all the leads on the tubes and getting them all in the sockets easier. I mean, you know, I can straighten the leads as much as I can by hand before, you know, before trying to put them all in the board and stuff. But there's, you know, there's kind of a limit to what you can do. And yeah, I think it's just going to, it's probably going to take a few beers and a lot of swear words. a lot of swear words. Let's see, bit 2. Yeah. Yeah. Yeah, possibly. I was thinking about that too. Let me see if I can. I don't know if I'll be able to really show the schematic very well because I don't have a digital copy of it. Otherwise, I could do like a screen share. I just have a printed copy of it. So maybe I'll put this in view. But yeah. Hang on. All right, over here. All right. Let's see. How many more of these guys? Maybe I will just solder the last 3, it looks like, of these A42 guys. Got 2 spares. That was rather nice of them. Yeah, and then I'll see about getting that schematic and see if I can put that on the table. Haven't spent too much time with it yet because it's all just happened yesterday. So, but yeah, it's definitely interesting. It's super cool to see to see things like that, you know, don't have a single integrated circuit in them, where you just have like single transistors and, you know, resistors and diodes, and like that's pretty much the whole entire schematic. And I have to say that I'm like, it takes me a little while longer to trace out what's going on like analog circuits like that. So usually takes me a little more thought and maybe some looking up of stuff. So where are we there? Awesome. These 3. And then over here. Cool. Yep, definitely a fan of that little iron. I can see why everybody likes it. It is, in fact, a nice soldering iron. And I hear that the tips aren't that expensive too, and that there are a lot of different ones. So maybe I'll see if it has a bent tip too, just because I like the weird bent tips. Awesome. Okay, let's see. I think we got all our transistors on there now. So yeah, let's see, we're basically left with our 470 ohm resistors and LEDs and battery, the 2 ICs that just get shoved in the sockets. And then, of course, all of these little teeny tiny sockets. Oof, not looking forward to this. All right. I'm not going to think about those for a little while longer. All right. I am going to quick grab the schematic. Here, you can look at that while I quick grab the schematic, and we'll see if I can put that on the table and get any kind of an okay view with it. I'll go this way. All right. Oh, that's not too terrible. Let's see. Of course, if I zoom out, I'm not going to be able to see it as well. Maybe there. And it kind of gets you most of it. So yeah. Right side up might help. So yeah, basically, this is like the schematic for one digit, I believe. It's just kind of crazy. It's like, yeah, it's a whole counter made of completely discrete components. So yeah, I believe, so you can see, let's see, over here. So we have plus 170 volts, minus 130 volts. And I think like we have a 20 volt rail. Yeah, then a 20 volt rail somewhere in there too, which I think is like sort of the ground equivalent. But yeah, it is definitely interesting. I definitely have to spend some more time with this to kind of trace stuff out. But this, I believe, up here is the tube is like basically one tube, and so let's see, 1, 2, yeah. So you have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And so those are all the digits. And then yeah, so it's hard for me to say like exactly where the problem might be in that digit. You know, like the 4 is over here. I think. Oh, there are 2 2s. What's going on with that? That's interesting. Or maybe there's like a digit number and a pin number? Oh, hard to tell. Yeah, I don't know. I'll definitely have to see. Yeah, older than you thought, right? Yeah, exactly. It's so there isn't a counter chip on there that's just, you know, putting out something in like in binary encoding. It's like entirely discrete. So hence it not being super straightforward as to what the problem might be. But yeah, it's definitely something that I'll have to like spend some time tracing stuff out. Yeah, and with the power off, of course, because got some nice high voltages going around in there. Oh, there's a minus 15 volt rail too. So yeah, our low voltage is like plus 20 volts and minus 15. Oh, interesting. So this one is a different HP one, copyright 1967. I'll have to see if I can find something for this exact counter. When I Googled the part number today, it was like, sorry, Google doesn't have any good search results for you. So yeah, it'll be interesting to see if what I can dig up with like spending a little bit more time on it. All right. Let's see. You're too close. Oh yeah. There we go. So where are we? What should we do next? I'm thinking LEDs next. They'll be a little bit challenging because they're actually a little bit fine pitched. So thank you. So we'll see if I can manage to do that, to solder these with this kind of fat tip without bridging. If not, then we'll go to resistors instead. So the other thing is, so we have an RGB LED here. They're 4 pins, generally red, green, blue, and ground. So it is directional. And like other LEDs, it has one flat side. It's going to be hard to see, but it's this side that has the flat side on it. And they have not seemed to put a flat side in these in the silkscreen. So which way do they go? Let's see if we can kind of figure this out. Figure this out also like without a microscope.
Is there a square pad that shows where ground is?
Yes, I think there is. There is one of these pads is a little bit square. So
third one.
Yeah, I think that one should be lined up with the longest one, which we can see is the third one in. So there we go. I'm going to solder this one first. Oop, maybe. Oh, this might be interesting. So, yeah, these holes are a little bit small. Let's see. Are they all a little bit small? It seems like it's just the square one. Oh, there we go. Maybe. Yep. Okay. Got it. Yeah. All right. And yeah, so the other thing about these LED pins is that you can see that there's a little bit of a fat part right here, it's like a little bit squished, and it's like the lead was squished in that one spot, so it's a little bit fatter than all the other spots, and that's to actually keep it at a consistent level above the board. So it inserts to that point, no more. So that's why this guy is kind of sticking up like that. It's just resting on those little fat parts. All right, let's see if we can. I'm gonna try to get 2 of these guys in. I'm gonna see if that one will go. Oh, yeah, okay, so it will go. It's just taking more force than I would usually do. All right. But it probably will make them stay when I flip them upside down. So yeah, I don't think I'm complaining about them being a little bit cozy. All right. Now we shall see if I can solder these with the fat tip without bridging. Might be a little bit challenging. It's definitely challenging on this. Oh yeah. To get the pad heated up, because this is such a fat tip. Because this is such a fat tip, and there's so little pad that comes out around this LED lead, it's hard for the iron to actually make contact with the pad and to heat it up. So when I first soldered it, it kind of wants to ball up above the pad instead of flowing down to the pad and making a nice joint. So I had to add more solder, and the problem with adding more solder is then you get a bunch of bridges like that, right? But we're not going to panic because anything that is soldered can be unsoldered. So this is kind of a big fat bridge, and I think I'm going to have to use solder wick to get it out, but you know, we might just try. Yeah. I mean, so my normal trick of just like kind of running it up the pad, like there's so much solder that or running it up the leads, there's so much solder that it just like keeps bridging. So let's see. I had some solder wick here, but I think I put it back in the other shop. So I will grab that. Okay. Back with solder wick. So I have 5 different thicknesses of solder wick here. And since I have like a fair bit of solder on this, I think I'm going to use like number 4. That might be a little thick, but that's okay. Is this number 4? It's in the number 4 spot. Oh, no, that says 5 on it. Haha, that's why it's thick. Let's see. And that is 2. There's the 4. Okay. So this is the wick that I have. It actually does have rosin flux in it, so it's a little gooier than no clean wick, but sometimes that means it works a little bit better. So, and I don't mind cleaning off my circuit boards. So I don't mind using the rosin wick. So basically, it helps to start with like a tiny bit of solder on your iron, because that just helps get everything moving. And then I'm putting the tiny bit of solder on the iron on the wick, and now the wick is wicking up the solder. I know that the angle on this one is probably kind of bad because it's like right overhead, and it would probably be more helpful to be outside. I don't know if I can do that, maybe. Yeah, then I can't see it, so sorry. I need to be able to see it a bit. So yeah, and now you can see that that the tip of this is kind of you know, clogged with solder now. So you can clip it off at this point, which is fine. Or since it's not, you know, since there's not like a giant piece out yet, I can just go a little bit down the line and use the solder that's already on there to kind of get stuff going. I'm just kind of wiping up and down the lead. Now I've gotten most of the solder off, and what I'll do is I'll just kind of come from this side, which I haven't really done yet, and I'm just going to kind of reflow all of these joints, again wiping in the middle a little bit, and we're pretty good. I don't, it's hard to say. I think that those middle 2 are still bridged. Yeah, they're totally still bridged. Might be at the point where like we actually need to like add a little bit of solder in order to grab that like tiny little part that's in the middle. I feel like we do. So sometimes removing solder is sort of this process of like adding solder, removing solder, adding solder, and removing solder over and over again until you finally like get it all. Ooh, there we go. So even though I just added solder, it finally like flowed to that little piece that was right in between the pads, and then it wicked to the rest of the solder that was surrounding the pad, and it's no longer bridged. But I would definitely say from this one experience of trying to solder that fine pitch stuff with this like big fat chisel-y tip, not ideal at all. So I think before Before I solder any more LEDs, or should I just, well, I should just do this one since it's already in here. We'll just do this one and maybe we'll get lucky, or maybe we'll be removing solder again. I could try to be fancy and try to drag solder it, but my drag solder skills are probably out of practice. Oh, that wasn't not half bad, actually. So sometimes you can get a bead of solder on the soldering iron and just sort of like drag from lead to lead, and it'll just like kind of perfectly go bloop, 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 and not bridge between them. And that is almost what it did here. Got one bridge. I know. I'm like, ah. All right, one bridge. I'm gonna try the thinner solder wick this time because I just need to remove like a tiny bit. Let's see. Oh yeah. So I'm using a combination of like wicking and wiping up the lead. And I think I got it. So yeah, that one looks pretty good now too. So I am going to clip these leads and clip these guys. And before I fire this up, I will probably just beep those out just to be safe. Or I might actually, ooh, we could look at them under the microscope. Should we do that? Let's try that. All right. one more video interrupting time. We'll see if we can get this to work. Yeah. So let's see. Where are we on this board? So that is the LED. It's hard for me to. Oh,
Light.
Yeah, let's see. That is in pretty decent focus on my monitor, at least. Let's get a little bit more flashlight light on the situation. So, yeah, you can see, I'm pretty sure that, I don't think that the two in the middle are the ones that I'm not entirely sure about, but I don't think that they're bridged. Of course, it's hard to hold this at a steady angle and also keep it focused because we're zoomed in so much. Let's see. Oh yeah, no, that's actually good. Let's see if I can keep a steadier hand on it. Yeah, I think that's good. That does not look bridged to me at all. Mm-mm. So I think we're good on that one. How about that one? Oh yeah, that one looks way better. So yeah, I think we're good there. The very bottom one might be a little bit light on the solder though. Usually for something like this, because I'm 44 years old and my eyes are, not as good as they used to be, I would actually I have a stereo microscope, and I would use the stereo microscope to actually look at this, and I would solder underneath it. This is just like an inspection scope, so it is monocular. It is very difficult to solder underneath because you have no depth perception. So it's cool for like taking really cool shots like this, but it's not great for actually trying to work underneath. Really helps to have that stereo vision, that depth perception. You don't miss it till it's gone. All right.
Switch back?
Yeah, we'll switch back. All right, so I think I'm just going to finish up these two banks of resistors here and probably call it good for the night after that. Just because I don't have another tip on hand for this soldering iron that's finer, and like frankly I might just want to solder those under the stereo microscope because it will be a lot easier for me. So yeah, I think I'll do those. I will do those off camera and later. And also like these guys, they're just going to be such a pain in the butt. And, you know, maybe I will live stream like drinking beer and cursing and trying to shove those in the hole because, you know, that might be entertaining. You can all laugh at me, but but maybe not. We'll see. So yeah, all right, let's get resisting. Last few. Well, there are a few more other than those banks. Now that I'm looking around. Do you want to do any soldering? You want to solder resistors?
I mean,
yeah, I could. Sure. So all of the resistor holes that are left should be the 470 ohms, and they're all written next to them as well. But we do have other extra resistors just in case I missed one of a different value. Let's see. It is a little difficult to, there we go. So I'm just doing the thing of like placing them in and then like shoving apart the leads on the back in order to keep them relatively in place while flipping them upside down. I'm not worrying about them being too terribly, you know, perfect. And then this guy, I'll do these two and then I'll turn it over. Cool. Awesome. Okay. Oh, you're good. Here, I can make this hard up. There we go.
Oh.
So yeah, that's the tricky thing, right? It's different. It's a different angle that I'm used to soldering at. Yeah, you can see it here. That's probably the easiest place to see if it's if it's like in the right spot. Yeah, spot and stuff. But
so is it this whole row here?
Yep, that whole row there, and I think that there's one more that's like over there.
Where?
There's like an empty spot right there.
Oh. Okay, yeah. So since
I know,
shoved
right?
my face into the board.
I know, it makes it challenging. I'm like, wow, I usually don't feel like I have a lot of thumbs, but
yeah,
when I'm at a different angle, I kind of do. Let's see if we can. Let's see. I don't know if we can get us both in the screen, not without the thing in the way.
Talk about your cool stuff while I struggle to solder.
While I struggle to get the resistors through the holes. Yeah, let's see.
I did it. I got one.
Excellent. I know it's different when you can't just like pick it up and put it where you want it. I'm gonna see if I can also enable the webcam. I might completely screw things up right now, so we'll see. Who gave her the StreamYard controls? hopefully we don't get like horrible horrible feedback and stuff. Let's see, let's do integrated camera from that one. Hey, there we go. And we'll do that. Mute this. Enter. Enter. There we go. And now we're there. Hey. All right. Hopefully this is still working out on YouTube and not causing any weird echoes or whatever. I guess we'll find out later.
This is just so strange.
Yes.
Oh man, how have you been doing this?
Yeah, nice. Yeah, just squish it in there. It's fine.
There we go.
All good. Excellent. Thank you, Brent. How many video streams can we make this poor computer have to deal with at
Before it
once?
completely melts.
Exactly. Yeah. I'm definitely going to have to bust that counter open and see about fixing that tube, or the whatever the drive for that tube is. But I think I have to brush up on some analog circuitry first.
It looks like one of them had the 5 and the 1 illuminated at the same time.
Yeah, and I've noticed that like that digit defaults to 4, but when I was paying attention to it yesterday when Tom brought it over, we were watching it and it didn't scroll up normally. It went like, I think it at one point went from like 4 to 3. So it didn't seem to like, there didn't seem to be like a predictable pattern that I could at least interpret at this point in time. But yeah, we shall see. I'm stoked that it works as well as it does. I wish the other thing that I wish kind of came across in video, which I know doesn't, because again, that depth perception thing, right? But like it's super cool with Nixie Tubes. All of the digits, you know, have an order, and they're all you know, they're all in front of each other or in back of each other. Here we go. Let's see if we can do this. So, you know, there's a digit and then there's another digit in back of it, and then there's another digit in back of that, and they're all each individually lit. And so, so the cool thing is that there's like this weird depth to the frequency counter display. So like, as I'm seeing it right now, the zeros that are lit are all further back, and then like the 4 is sort of more in the front, and the 5 is even more in the front of it. And so it like, you know, you're not used to, or at least I'm not used to, seeing a display on a piece of instrumentation that has the different digits at different depths. You know, I'm used to just one flat panel with all of the digits displayed, but here it's just like, it just gives it like a cool look. Definitely mad scientist. Now we need a Jacob's ladder in the shop. And a legit theremin, I think.
Yes.
Yeah. But yes, Let's see. We can. So yes, this is the tube with all of the sockets on it. Nice. Soldering. 3D. Yeah, it is like a 3D display. No glasses needed. I just love too how like people decided to optimize the order for minimal occlusion of digits. I think that's an excellent just kind of like OCD engineer thing. Like we could put the digits all in order, or So what do you think of that soldering iron?
I really like it.
Yeah. I think my only complaint about it is that you cannot change the tip while it's hot without some sort of like gloved protection.
Yeah.
And
that's how the other one is though, right?
I guess, yeah, the Metcal, but you could take like a pair of pliers and just yoink a Metcal tip out, since it's just shoved in. It's not like screwed in at all.
Right,
the Weller, the Weller though has the plastic insulated part, so you can actually change tips while it's hot.
Mm-hmm.
Yeah, so that would be my only minor gripe, but it's really not that's a super minor gripe. I try not to change tips when it's hot anyway, just because I don't want to accidentally burn myself. Cool. Nice.
I forgot my face was on camera, and I feel like I was like sitting with my eyes super wide open trying to see.
I'm sure YouTube will choose the perfect one for the, for the thumbnail. Yeah. It always does.
Well, I'm gonna hand this back over.
Back
to
over.
You.
All right, I'll finish it up.
Oh wait,
here.
Yes.
Cool. Yep. Have to do musical chairs now.
Wheel over.
Oh, now you get to be other Carrie. You can turn that one off if you want. You can, just click remove. Awesome. All right. The home stretch of 470 ohm resistors. I love it. Woohoo. All right. Well, there's one there hiding out. I see you. Let's see.
Sorry.
No problem. Yeah, definitely requires like in and out of the weird fisheye magnifier. Let's see. Okay, I can't forget to actually solder that one now that I've put the resistor in. It's kind of a lone one over there. So maybe I'll do these two lone ones too. I'll do all of the ones in weird spots and then do that row. 1, 2, 3, 4 resistors to solder.
So did you say that these are old Russian?
Yeah, they're old like Russian stock. Like for a while, I don't know if they are still being made in Russia or not, if you can get like new ones, but for a while, it's old technology, and so LEDs kind of like the 7-segment LED displays kind of took over for displaying numbers.
Mm-hmm.
And once that happened, they're low voltage, low power, what's not to love about them, and Nixie tubes kind of just died out. So all of the companies that were making Nixie tubes stopped making Nixie tubes. And for a while, like you could only like the only new ones that were being made were Russian, and I don't even know if that's still the case, if you can still get new ones at all. and they keep on, they're kind of almost collector's items now. When I bought this set of Nixie tubes, I mean, they used to be mass produced and super cheap, but now that set of Nixie tubes, I think it was like a set of 6 that I got off of eBay, and it was around like maybe $65 or something. I can't remember how much shipping was. Might have included shipping. But yeah, now I looked up the same set of Nixie tubes from the same seller, and they're now like over $100. So like 15 bucks, 15 to 20 bucks a tube now. So it's kind of expensive. Which is kind of why I procrastinated on doing the clock kit, because I was like, oh, I really want to like spend $100 on like a stupid clock. And so, I bought the kit, and then I bought the tubes a few months later, and just spread out the pain.
Yeah.
All right. Soldered those 4. I think we're just down to this last row of resistors right here. And then all of the difficult to solder LEDs, and then all the difficult to solder sockets. But that will be another day. All right. Let's see, how many are there? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Excellent. They gave me a few extras. And we're gonna organize our little leftovers here. I could even remark my resistors. Screw the color code. Yes. All right. Could you put that in the little extras bag? Awesome. Thank you. And let's see. Dalibor Farney making new tubes. Interesting. I will definitely Google that person. Yeah, it's a shame that they are not really being made anymore. I mean, they're super cool. They're really pretty. And like, I think the other thing that I like about Nixie tubes too is that there were different fonts, there were different styles of digits used. And so like, and some are more roundy old school, some are more square and like almost look like 7-segment LEDs. And yeah, like, so the ones that I have are IN14s. That's the name of the series of Nixie tube. Yeah, this is definitely hard to do with a lot of stuff in the way. All right. And so yeah, the ones that I have, the IN14s, I liked them because they had like a nice roundy kind of style of font, like very sort of, 1950s, 1960s. And the other thing that was kind of interesting about them is that, which honestly, I would prefer something slightly different, but that's okay. Oh no, that resistor's upside down compared to the other two. Whew, can't have that. That's just like not allowed. Doesn't matter if they just all have to be one way.
Don't look at mine. I wasn't paying attention.
You put them all in the same direction.
Did I?
Yeah, you did.
Oh, nice.
That's why I was like, oh man, mine can't be like all cattywampus. Ours look all nice. So the other thing about these particular Nixie tubes is that the 2 and the 5 are actually the exact same digit. It's just that the 5 is an upside down 2. So it kind of looks a little bit funky, but I mean, if all things were equal, I would prefer a 5 that is stylistically different than a 2, but that's okay. I didn't have a ton of choices on eBay. And I remember like the choices that were available at the time were they were a lot of the more modern looking fonts for the digits, which I didn't like. I mean, if you're going to make something out of Nixie Tubes, it should like look like the era that Nixie Tubes are from, in my humble opinion. And I have to say that I do like the digits on that electronic counter. They are very nice and roundy, and the 5 is distinctly different from the 2. Okay. Woohoo! Last row. Huzzah! Choo! Around now. That way. All right. These guys. Those guys. Oh man, I think we are almost there. Probably not going to put the battery in until the very last either. Right there, just, you know, because it's generally nice to leave things unpowered until you have to power them. So yes, so I will do the LEDs, these RGB LEDs, then the sockets, and then the battery. But I'm like looking all along this guy, and I'm just trying to see if I missed anything else. Oh, and I'll put the ICs in their sockets at the very end too. And I don't think I missed anything. I think it looks all good. Woohoo! Woohoo! Yes. Awesome. All right. Well, thank you very much for coming to this live stream. Thank you, Brent, for all of your excellent information. It is always a pleasure speaking with you and chatting with you. And yeah, we'll do this again next Wednesday. I don't know what it'll be next Wednesday. It won't be more Nixie Tube Clock. I promise. We'll do something different. But yeah, if you have any specific requests, definitely like let me know in the YouTube comments. I have some other kits, and I have some other just kind of like normal assemble kits. One of them is another Cyber City circuit kit that is like a little sound sequencer. And then I also have some wearable kits, so a little bit of sewing and electronics, and that might be kind of fun too. So, all right. Well, thank you all. Awesome. See you later.